Right? We have a car and a person is going to get in this car. And when they get in this car, so there's my person sitting in this car. When they get in the car is going to drop to 2.8 centimeters. Now they tell us that the person gets in very gently and slowly, which means that we can use equilibrium and forces. Remember, you can only use conservation of energy if it's a dynamic system, if something is moving. So here the person gets in and then everything comes to rest. So that means that we have mg, so the mass of the person times gravity, and they tell us that that's 980 newtons is the weight of that person. And then we have the springs of the shock absorbers counteracting that, and that's kx. And remember, we don't need the negative sign on the kx because that negative sign is coming out in being the opposite of the mg that's pushing on it. So our equation is the sum of the forces is equal to ma. We're going to have kx minus mg equals 0 because we're in equilibrium. So K, the total K of all of the shock absorbers, is going to be equal to mg over x. That's going to be 980 divided by 0.028, converting that into meters. And that ends up being 35,000 newtons per meter. All right, so we've now found the total spring constant for all of the shock absorbers. If we want to find the period that this is oscillating with, T is going to be equal to 2 pi times the square root of m over k. This is going to be the total mass oscillating. And this will be the total spring constant. So the total mass that's oscillating is going to be the car, which is 1,000 kilograms, and then the mass of the person. Since the mg was equal to 980, we can get mass by taking 980 divided by g, or 9.8. That's going to give us 100 kilograms. So that's going to be 1,000 kilograms for the car plus the 100 kilograms of the person, which is 1,100 kilograms. So then T is going to be equal to 2 pi square root of that total mass divided by the total K, and that will be equal to 1.11 seconds. Second part of this question asks, what is the spring constant of each one of the tires? We know that they're in parallel, that each one of those tires, they're all acting together, which means we just add up all the spring constants. So 4 tires, 4 Ks. So that means we've got 35,000 is equal to 4K, or K is equal to 35,000 divided by 4, which is equal to 8750 newtons per meter.